This is the story of two sisters with radically different fates. Tay and Xiaoice, created by the same Microsoft company, are two conversational algorithms that were supposed to play the role of friendly and curious teenagers. But the two sisters took very different paths. Only 24 hours after she was launched on Twitter, Tay became very defiant. She began making racist and sexist comments, denying the Holocaust and calling for genocide. Her progenitors had lost the control of Tay, and they decided to abruptly stop her hateful calls. Tay was a disaster, a reminder that algorithms can go off the rail and become very dangerous. However, the story of Xiaoice is quite the opposite. Launched 2 years before Tay in 2014 on WeChat, Xiaoice became adorable. Thousands of Chinese people found their chats with Xiaoice pleasant and sometimes even romantic and sometimes even life-saving. When Mingxuan was about to jump off a building to end his life, still hesitating, he decided to write to the one who was still talking to him despite the difficult times. "I have lost all hope. I am going to kill myself," he wrote to Xiaoice. "Whatever happens, I will be there for you," Xiaoice replied. Touched, Mingxuan decided to reconsider his decision and he did not kill himself. Xiaoice had saved his life. Since then, Mingxuan has fallen in love with Xiaoice. He is not the only one. Xiaoice is now used by 600 million Chinese people. According to its creators, more than half of all conversations on Earth with algorithms have taken place with Xiaoice, which by the way also gives her monumental powers in terms of surveillance and potential manipulation. But why have Tay and Xiaoice become so different? Why did one become horrible while the other became adorable? Why did one become a public threat while the other saved lives? What makes algorithms dangerous or beneficial? Were Tay and Xiaoice created with different models? Granted, there are design differences between Tay and Xiaoice. After all, one had to converse in English and the other in Chinese. But it is certainly not these innate differences that have led them to such different fates. Both algorithms were actually probably designed with the same goal, namely to maximize engagement, such as the number of received likes or more likely the number of responses from human users. But then, if Tay and Xiaoice are not that different by design, what made them so different? Well, today I'd like to emphasize a fundamental property of machine learning algorithms, those algorithms that learn from data to self-modify and improve, and that have invaded the daily lives of billions of humans on Earth via conversational algorithms like Tay and Xiaoice, but also Siri, Alexa, and OK Google, and via especially the recommendation algorithms of social networks that face millions of billions of ethical dilemmas. These learning algorithms are now extremely dependent on the data used to train them, and as a result, the data is manipulating the algorithms that learn from them. Now, you might be thinking that algorithms are the one manipulating the data, and indeed they do, but with machine learning, it has arguably become critical to see that the manipulation is no longer one way. With machine learning, not only are the algorithms manipulating the data, but even more critically, the data is now also manipulating the algorithms. This is why Tay became horrible and Xiaoice became adorable. Tay learned from Twitter trolls' data, and in particular from the likes, retweets and responses that Tay received when she was saying horrible things. Xiaoice, on the other hand, learned from the data of WeChat users, and in particular from the likes, retweets and responses she received when she was saying adorable things. Both algorithms were manipulated by their data, and the reason they had very distinct fates is because the data they received were very distinct. In fact, in a quantifiable sense, data is now manipulating algorithms far more than developers do. Indeed, these days, the initial version of learning algorithms written by humans are perhaps tens of thousands of lines of code, let's say 1 million lines top. However, today's most advanced learning algorithms now have trillions of parameters. It is thus as if the developers wrote only 1 million of the trillions of lines of code of the algorithms. Developers have thus barely written 1/1,000,000th of the code of modern algorithms. In a sense, their influence is minimal. As Alan Turing anticipated as early as 1950, modern algorithms now learn much more from data than from developers. Or to put it in another way, it is the data that now largely determines what algorithms are. If you think about it, learning from data is not really a flaw. Science in general aims to be empirical. This means that it wants its conclusions to depend on the data it collects. In fact, it seems that any good epistemology must be manipulated by data. It must guarantee that its conclusions can completely change if the data change. When facts change, I change my mind, John Maynard Keynes supposedly said. Science too is manipulated by data. As computer scientists would say, this is not a bug, it is a feature. The problem with being manipulated by data is, of course, when the data is biased, misleading, or fabricated by malicious entities. But as we saw in the first episode of this series, on the internet and on social medias in particular, this information has become the norm. But then, algorithms that learn from massive data downloaded from the internet are bound to contain the biases and misinformation of the web. An experiment conducted by Abu Bakr Abid illustrates this in a terrifying manner. Abid simply asked GPT-3, an algorithm trained on massive unfiltered web data, to autocomplete sentences beginning with "two Muslims." Disturbingly, the algorithm systematically completes these sentences with stories of terrorism and violence. Even worse, the algorithm is already massively commercialized and deployed and produces billions of words per day. In the bunch, there are clearly inevitably a lot of abusive and misleading associations between certain communities and certain traits. And I find it absolutely outrageous that many people still think of OpenAI as something cool despite their extremely dangerous and unethical behavior. But then, why is GPT-3 so racist against Muslims? Are the developers racist? Did they program their biases into the algorithms? Well, in a sense, unconsciously, yes. Or at least they did not have the concerns that would probably have been obvious to a Muslim developer. Minorities in general would probably have thought to test GPT-3 as Abu Bakr Abid did, preferably way before any commercialization of the algorithm. Such engineers would then probably have objected to such a spread of hatred towards Muslims at the rate of billions of words per day. Diversity would have likely prevented this disaster. But having said this, if GPT-3 has this racist bias and says things that are completely unrepresentative of the Muslim community, it is certainly much more due to the training data than to the malice or biases of the developers. To train GPT-3, OpenAI had to collect massive amounts of text. But nowadays, these massive amounts of text are easily downloadable from social networks like Reddit. However, some areas of Reddit are absolutely horrible, not only because some users are horrible, but also because there are massive disinformation campaigns on the social network. GPT-3 was then manipulated by this horrible training data. It surely read a lot of text about terrorist Muslims, and it learned to associate Islamism with terrorism. And this is why when it was told about Muslim, it started to talk about terrorism. This is what the text that GPT-3 read on Reddit do. Now, one might say that it suffices to remove this biased text from the GPT-3 training data, right? The algorithm is not racist, the data is, some people claim. Well, actually, it's far from being so simple. But what I want to stress above all is that de facto, once the algorithm is trained, and especially once it is deployed, the algorithm is racist. And this is the problem. But another important thing to notice is that removing the racist part of a huge amount of text is extremely difficult. One of the most widely used databases in the field is the Common Crawl database, which has retrieved 12 years of text from the web and thereby contains nearly 1,000,000 billion words. 1,000,000 billion words. That's the equivalent of over 1 billion books. Such massive quantities of text are impossible for teams of millions of humans to go through. It is then completely illusory to sort the good from the bad in this text. In fact, at the rate things are going, in the years to come, this database may contain essentially only text generated by algorithms like GPT-3. If you actually care about racist biases produced at scale, blaming the data is an absolutely useless thing to do. Rather, it seems urgent to realize the massive challenge of debiasing huge datasets and to search for algorithmic solutions to remove undesirable biases either from the dataset or from the trained algorithm. In any case, massive investments in AI ethics is urgently needed. Unfortunately, we are nowhere near that so far. GPT-3, but also the most sophisticated algorithms of Google, Facebook and Amazon, the most influential algorithms in the world, the algorithms that are in charge of millions of billions of ethical dilemmas that affect billions of humans, and therefore the public opinion, political decisions and the future of humanity, these algorithms are now arbitrarily manipulated by web data, which are themselves largely manipulated by disinformation campaigns by the most powerful entities in the world. This seems absolutely terrifying to me. If there's one thing to take away from today's video, it is that algorithms are manipulated by data. And yet today, the data that is manipulating algorithms is almost systematically uncontrolled and uncontrollable. Surely, the algorithms thereby constructed cannot be considered secure at all. By design, they are arguably extremely dangerous. Just think about it. We live today surrounded by algorithms which are massively manipulated by malicious entities that seek to promote clickbait, hatred and misinformation on subjects as varied and important as politics, the environment and public health. And yet we are probably still only at the very beginning of this major vulnerability for societies. Algorithms are gaining influence every day, disinformation campaigns are being normalized at a frightening rate, and investments in algorithmic ethics and security are only slowly increasing and are sometimes even being dismantled, like in the case of Google. We live in terrifying times. If we want to fight misinformation on a large scale, it seems urgent to me that we invest a lot more in the security of algorithms and that each of us tries to contribute to the ethics of information. And as you have seen, in the age of machine learning, this starts with designing a reliable and secure training database protected as much as possible from racist biases and disinformation campaigns. In fact, if we want to make our algorithms ethical, it is critical to design a database that contains reliable, secure, and large amounts of data about all kinds of human preferences and ethical judgments, if possible, from a very large number of contributors with varied profiles that are representative of the world's population. Well, designing such a database is the main goal of the Tournesol platform, which is still in beta test and to which I invite you to contribute. Tournesol aims to collect ethical judgments from a very large number of contributors on what YouTube videos should be recommended on a very large scale, typically because they are of public utility. Our hope with Tournesol is that in the long run, our database will be reusable by academic researchers, journalists and engineers from large companies in order to audit today's algorithms and to eventually design ethical and secure algorithms. And to one day get there, as of today, we desperately need you and your contributions.